All right, welcome everyone to week 2. This week, we're going to be taking our first steps in the world of JavaScript. So there's a bunch of new syntax that can be kind of confusing, but I want to try and make this as simple as humanly possible. So last week, we covered CSS in addition to the little bit of HTML that we did in week 0. And we did a little bit of actually making a website that looks hopefully slightly better, or we at least know that there are possibilities out there to change the CSS using these selectors and using these properties. And we're sort of ending up with something that looks like this. We have this sort of dead skeleton from our body analogy. The skeleton is the HTML, the clothes are the CSS. The skeleton is wearing clothes now, so that looks a little bit better. But this week with JavaScript, we're going to be adding some life to our skeleton. So it's a walking, talking thing that has something in it. So yeah, this lecture, I want to introduce JavaScript. I'm going to be talking about variables, which are like these boxes that you can put things into. We'll be talking about different data types. So it's like the stuff that can go into these boxes, like what variations of the stuff can go inside of these boxes. And alongside that, we'll be talking about operators, which is a really confusing sounding word for something that's actually quite simple. An operator is just something that we can do with some of these data types. So yeah, lots of new syntax this lecture. I'm going to try and make this as simple as possible for each of these. And then finally, functions we're going to be talking about, which are like some Lego blocks of code that we can clip together in interesting and useful ways to make our lives as developers as easy as possible. Okay, so just some words on JavaScript in general before we get started, just like a broad introduction. JavaScript was famously invented in just 10 days by this guy down here, Brendan Eich. He was one of the first developers at Netscape, and they needed some sort of language that they could use to make their websites interactive. Netscape was one of the first web browsers that came out back before the whole AOL days, where you'd have a disk to install one of these web browsers. Important that JavaScript is a totally different language to Java. They actually took the word JavaScript from the word Java. So originally, JavaScript was called LiveScript, Netscape, the one that Brendan Eich created. And they changed the name to JavaScript because Java was like the really sexy programming language that everybody was really into back in the like early 2000s, late 90s. But it's super confusing if you're ever talking about JavaScript to a non-technical person, and they immediately think, oh, Java is this programming language, which is also super popular. So these are two different things. Java is mainly like more of a back-end language or a language to make applications. JavaScript is something that's used by the web browser, but we'll talk about that later in the lecture. It's also known as ECMAScript. I think ECMA stands for the European Computer Manufacturers Association. We have it right here. So you'll see different versions of JavaScript being called ES something or other, and that's short for ECMAScript something, which is basically just like saying JavaScript. So none of this is super important. Just a little bit of padding around the lecture, make it seem a little bit more interesting, hopefully. So what is JavaScript exactly? Like, what do we use JavaScript for? Well, basically, JavaScript is active whenever we make a click or drag something on a screen that has some sort of reaction. If us doing something as a user causes a page to update, that means that JavaScript is running in the background, and JavaScript is handling these user events and doing something. So for example here, you might see this pattern quite a lot when you can sort of click on an image gallery and you can kind of flick between them, pressing buttons. This all happens on one screen, and JavaScript is responsible for bringing that display up and handling these user clicks. So that's something. Another example here is something like Twitter. You click on this button, you start typing something like some sort of GIF that you're searching for, and a whole list of GIFs come up. This is JavaScript that's sensing this user input, sensing the typing, and it's making some call to some external website to grab these GIFs, and then it's displaying it to you. So this all happens through JavaScript. We couldn't do something like this with just HTML and CSS. Another example that we thank JavaScript for is storing user data between screens. So you might have heard of this thing called cookies before and wonder what this means. When you go into a website and you get this box screaming at you, asking you for consent to take cookies from you. A cookie essentially allows a website to track some information about the person that's using it. So in kind of a nefarious, bad way, like companies can track you across multiple different websites and sort of figure out the inner workings of your mind through which sites and which Google searches and which friends you have on Facebook or whatever. But it's also like really important just to be able to keep you logged in. So when you're on a particular page, if you navigate to another page, if the website or your browser doesn't have a cookie that it can track, okay, this is this particular person, then you would need to re-sign in every single page. So we get some shortcuts from that are really useful in terms of user session storage and cookie storage on the client. So this all happens on your web browser. Your cookies live on your web browser, not on the server of Facebook or Twitter. And it's a way of tracking you between pages, but also tracking that, okay, this person signed in, this is this person's email address and account details that go at the top of the screen, for example. And we can do pretty much anything that you can think of with JavaScript. There's always some library that's been invented to make something like this fairly easy. So, example like this, JavaScript can get the position of the mouse. It can get whether the mouse left click button has been held down. And it can say, okay, well, if the left click button's been held down, we can start drawing something on the screen. And then there's also JavaScript involved in saying, okay, when you press the save button, that saves this particular image, or you press the clear button, it wipes the whole slate clean, kind of. So all this possible with JavaScript. But we can really do pretty much anything with JavaScript these days. I think I probably touched on this already in one of the intro lectures. There's a framework called Node.js that allows us to create servers using JavaScript. So usually JavaScript runs in your web browser. We're going to talk about that in a few slides' time. But with Node.js, you can actually give it access to your computer's file system, which means that you can create a server. You can be looking things up in a database that's on the computer, basically. And later on this course, we'll be using something called Express to help us to make a backend for a website. So if it seems kind of complicated right now, don't worry about it. We'll cover it in about week 7 or 8. So yeah, totally okay for now not to totally understand this. And the other example I have here is a framework called Electron, where you can use JavaScript to create desktop apps. So for example, you think about something like Discord or Slack. There's a web app, which is probably written in JavaScript, something like React or something like Angular. Normally, before Electron was invented, if you wanted to make a desktop app, you'd need to completely rewrite your code. You need to make something that runs on a desktop. Maybe you need a separate version for Mac OS versus Linux versus Windows. Electron lets you make a desktop app that runs on all operating systems, and you'd be writing your code in JavaScript. So you could create a React app written entirely in JavaScript, and you could use that to generate a desktop app that you can then send to people's desktops, and then they can have that on their desktop app. So yeah, really anything we can do with JavaScript. It's a magical language. It's a great language to be learning in the 21st century. Okay, so in terms of how we actually include some JavaScript, like where it lives. So as I mentioned at the start of this lecture, JavaScript is running in your web browser. JavaScript by default is installed in every web browser. It's the only language that has this. Usually, if you want to use some sort of, if you want to download a new language, for example, if you wanted to download Go, or if you wanted to use C or Python, any other language, you'd usually need to download that onto your computer first. But the great thing about JavaScript is that it's already pre-installed on all web browsers. And as long as we have some JavaScript included in an HTML file, that JavaScript is going to get executed by a web browser. So there's a few different ways that we can include JavaScript. I'm going to talk about two of them. One way is to use a script tag in our HTML. And this should look really similar to the style tags that we used with CSS. If you put a script tag somewhere in your HTML, you can immediately start writing JavaScript in between these two tags, and that will automatically execute when your page loads. And then similarly, also similar to the CSS, it turns out that you can link an external JavaScript file, and that will link that into the same place. So basically, it's almost the same thing as using a script tag and putting some JavaScript inside of it. But in this case, it will just grab whatever's at this path. So hopefully that's a JavaScript file, and it'll basically copy paste that code in here. And yeah, as usual, as also with the CSS, it's nice to be able to separate things into different files. So if you ever get the chance, I would always recommend you should write this syntax rather than this syntax. But just for getting going, it's quite good to know about both of them. So in the end, you should have something that looks like this. This is with the first example of just putting a script tag and writing a JavaScript directly. You should be aware that the script tag, normally, any JavaScript code, we write at the end of the body. You might think that this should go in the head, but there is a good reason for why it goes at the end of the body. The reasoning being that JavaScript can sometimes be editing stuff that's on the page. And we want to make sure that all of this HTML is actually rendered before our JavaScript starts executing, because we might be wanting to do something with these elements on the screen with our JavaScript as soon as that loads up. So the convention is always that the script tags are going to go at the end of the body, like right at the end of the body. Okay, so that's a little bit of introduction of how we include JavaScript, and a little bit of an introduction vaguely in terms of what JavaScript is. I want to go through here just like a step-by-step conceptual introduction of how JavaScript works. As I've mentioned a couple of times already in this lecture, JavaScript runs in your web browser. So this is something like Google Chrome, or it's Firefox, or it's Safari. And one of the main things that we use JavaScript for is to programmatically change the HTML and CSS on the page. So what I mean by programmatically is saying, okay, we can react to some event, let's say, a click of a button or typing something into a form. And when that event happens, we can then do something in our JavaScript. And that something could change something on the page. So this is going to become clearer and clearer as the course progresses. We'll be actually editing stuff on the page, the lecture after next. But this lecture is just more of an introduction to lots of syntax surrounding JavaScript. And that will also happen next lecture as well, before we start applying it to our HTML file. Okay, so how does JavaScript work? Well, whenever your browser sees some JavaScript code, so a block of JavaScript code that we put inside of our index.html file, or we've linked from our main.js file or our index.js file, your browser sees this code. It's going to execute the code line by line. So first it reads the first line, it executes the first line, it reads the second line, it executes the second line, and so on, all the way until it's finished all the JavaScript that it sees. And if the browser sees anything that it doesn't understand, it stops running at the line it was on, and it creates an error message. And you can see the error message in the console. It's kind of important to realize that this is going on, just because in general, computers are kind of dumb. We think that computers are kind of smart because they can do lots of things that we can't do, like calculate 10,000 numbers added together in 10 seconds. No problem for a computer. Lots of problem if a human being wanted to do that. But in terms of thinking outside of the box and sort of viewing something and sort of reading between the lines of what you're trying to get out of it, computers are really stupid. So I have this video that's attached to bonus homework this week, which sort of goes through a scenario that hopefully gives some intuition on how computers read instructions. And yeah, it can happen quite a lot that you have some line in your JavaScript that's causing an error. That'll crash the entire program, and you think, okay, what could possibly be going wrong? And it turns out that the machine has been sort of literally looking for something that that you didn't provide that seems really obvious. This is a really common thing to happen programming. And I think you'll probably see this yourself just from practicing a few times, trying to get some sort of program to work. Okay, the console we've talked about a little bit already in this course. I introduced this way back in week 0. The console is for sort of seeing what's going on as like secret messages that you leave yourself from your JavaScript code. So back here in this file, this is the same one that we're showing on this console slide. We have this console log of a secret message, and we can see in the console, okay, that's where that secret message popped up, essentially. Yeah, this is constantly used for error checking, and we can even write things in the console. We can even write JavaScript in the console, which I'll show in a little bit. Okay, a little bit of syntax, a little bit of definitional stuff. We have this concept of a statement in JavaScript. And a statement is one single instruction that we want JavaScript to do. So here we have 3 statements. The first one is logging out hello world to the console. It will show up here. The second one is logging out hi there. And the third one is logging out dogs are the best. So each one of these is a statement, one instruction, basically. We also have comments in JavaScript. There are 2 ways of writing comments. There's a multi-line comment, which starts with a slash and asterisk. And when you want to cut off a line comment, a multi-line comment, you can cut it off with a star and an asterisk, the other way around. Or alternatively, you can write a comment for just 1 line if that line starts with 2 slashes. I think I've mentioned this a few times, probably with HTML and with CSS. Every framework, every language that you use has a different syntax for multi-line or single-line comments. Comments are great just for leaving a little bit of instruction to other people who read your code of what the code's doing. So you'll often see these. You often might want to write some comments, especially if you're working on code that's shared with other people. And even writing comments for yourself. If you program a program and then you don't see it until like a year later, it's really easy to forget what particular lines of code was doing. So yeah, writing comments is a really good habit to get into, and this is how we do this with JavaScript. Okay, so three functions I want to talk about that come out of the box with JavaScript that let us get some results on the screen. The first one is this alert syntax. So this is a statement that we can write in our JavaScript file. We just write alert and then some sort of message. And if we do that, we get this pop-up on the screen. So you might remember, if you're old enough to have been messing around with the internet back in the 90s, these were absolutely all over the place. You had this sort of like never-ending hell where you have to get rid of like 10,000 pop-ups that just pop up on the screen. Turns out this is still totally possible. I'm not sure why we don't see that many of them anymore, because yeah, it's still a super easy thing to do with JavaScript. Yeah, so you just make an alert, some sort of message, and it pops up. This website says hello world. Console log, I explained already. A console log is writing a message to the developer console. And you can see this as normal by going into the development tools and clicking on the console tab. The other option for getting some sort of result on the screen is the document.write syntax. So again, all of these three broadly the same in terms of we have some sort of lettering here that describes what we're doing: alert, console.log, document.write. And then we're just leaving a message inside that. And these three ways of getting results on the screen do it in slightly different ways. Document.write will add whatever we put in these brackets to the end of the document. So you notice this is all the same example here. This is the pop-up, this is the console log. With that document.write, we got this hello world just appearing at the bottom of the screen. So most of the time, if I'm trying to debug, if I'm trying to figure out what's going wrong with the problem, I would tend to use this console.log, but useful that we have all three of these that we can make use of. Okay, so I want to give a quick example. So here we are on the WOOFCODE website. And I've opened up my console. There's a shortcut on a Mac. I think it's slightly different for a PC, where you can go Command Option J, and that opens up the console. So that's kind of helpful. And yeah, so we can go console.log hello class. And this shows up inside of the console. So writing stuff here is pretty much identical to writing stuff in your JavaScript files. You can even call functions, which we'll display later, and you can access variables that we've stored at the global level, which also should make sense later, hopefully. So everything is available here that's available in our JavaScript files. And yeah, so we can do pretty much anything with JavaScript. So we can write some numbers out. So we're adding numbers together here. This gives us the result. 3 is less than 6. It's true, makes sense. So JavaScript's already installed on this web browser, and it understands us when we write JavaScript in this console. So I'll be giving a little bit more of a demo on that later. Okay, so that's a really quick introduction to JavaScript as a whole, what it's all about, and how we get going with it in our files. The next sort of section of this lecture that I want to talk about is variables. This is sort of one of these foundational concepts in programming, to kind of be able to program things, to be able to do things with our computers. I want to sort of cover a few different topics surrounding variables. I have this analogy with variables where a variable is sort of like a box that you can put things into. So we'll be talking about, okay, how do you set one of these boxes up? What is the syntax exactly to put something into the box? And we'll be extending that metaphor a little bit further. So that's kind of explaining what variables are. We'll talk about this in the next few slides. We're also going to be talking about what you can do with variables, which is sort of like this operators word. Again, like sort of meaninglessly complicated word for something that's so simple. What can I do with the variables when I have them? And the last part is going to be talking about what sorts of variables, what sort of types of things can we store in these variables. So hopefully this makes more sense as we go through these slides. Okay, so first thing I want to talk about is setting up one of these variables. So as I've said, a variable is pretty much some sort of container, some sort of box that lets us store things in our code. So this is really important because it means that we can refer to these boxes later on in our programs, and we can keep track of many different values at once as our program executes. So in this case, okay, so we're declaring a variable. This generates this sort of imaginary box, and every variable has a name. So you can think about this as like a name tag on the front of the box that lets everybody know, okay, that's the box that I put the message in, for example. So that's just declaring variables. The syntax to do that is let and then the name of the variable. So this is sort of like saying, okay, generate one of these boxes and put the name tag of message on that box. This is what this line does here. And this is called declaring. Declaring in the sense that I'm declaring that this box should exist, and like magic, the box comes into reality in our program. There's another syntax that we can use to do this, which is initializing a variable. So again, we have the let and then the name of the box. And then we have this equals sign, and we have something that we're putting into the box. So basically how you read this is saying, create a new box called message, and I want to put hello into the box with the equal sign. So the equal sign in JavaScript, in most programming languages, used in this context is assignment. So we're assigning the thing on the right to the thing on the left. Don't confuse this with equality. We're not declaring that, we're not measuring, okay, is message equal to hello? We're only using this in terms of assignment. So I think that that'll become more important next lecture when we talk about true or false values. But yeah, for now, remember, okay, there's one way of declaring a box. I just want to create a box. It's empty. I can do things with the box later. Or if we put an equal sign after it, it says, okay, create a box called message, and it should start off with the word hello inside of it. So that's what's going on here. Yeah, and so it's possible to write something like this. So in this case, that's more or less kind of another way of writing this one and this one. So in this case, we're starting off with an empty box called message, and then we're assigning the word hello into that empty box. Usually, if you're doing it like if these two lines are right after each other, then you would much rather do something like this. But sometimes you might want to do this later, or you might want to do this only in certain conditions. So this is another way of initializing a value to a box. Yeah, make an empty box with message and put hello into that box called message. It turns out we can also reassign these variables. So in this case, the example again, okay, we're creating a new box called message. We're putting the string of hello inside of it. If we write message equals something else, then that throws out the thing that we had inside the box at first, and it puts the new value on the right inside of that box. So this is called reassignment. The first thing of like putting something in the box for the first time is called assignment, and changing the value to something else is called reassignment. Okay, so we've been using this word called let so far to create a variable. There's actually 3 different words that we can use to do this. One is called var. This was the most common one. It was the only one that we could use until 2015. After 2015, there was a big update to JavaScript, and it replaced var with let and const. So these are the 2 options that we should use now. It turns out that var still works. You can still make a variable using var, but it's generally preferable to use let or const, because let and const gets rid of some of the funky behavior that you find with var in old JavaScript code. It just makes some of these weird behaviors that happen when you use var disappear. So this was an improvement to using var that came out 5 years ago. So wherever possible, use let and const. The difference between let and const is that with const, you're not allowed to reassign a variable to something else. So if we assign a variable, initialize a variable, creating this box called message, putting the string of hello inside of it, and we declared it with const. Const stands for constant, which means, okay, we're saying, okay, this message is never going to change. We're always wanting we always want message to equal this particular string. And if you try to reassign something called const, then you get this error that will show up in the console, and it'll break the execution of the program. The rule of thumb is to use const wherever you can. And then if you decide at some point, okay, actually I need to reassign this variable, I need to change the value of this variable using this reassignment syntax, then you can switch it to let. So start off all the time using const, and if you decide at some point, okay, I need to reassign this, then you can change it to let. Okay, so next thing I want to talk about is values of variables. So we have these boxes, we can put stuff into it. A value is a thing that you can put into the box, basically. And yeah, variables have different types. And we can work with different types in different ways, as we'll show. And yeah, the value can change over time through reassignment. Through a reassignment, basically, or using different operators. Naming variables. This is a good little segue to talk about now. There's a few rules when coming up with a name of a variable. So this is the sticker that goes inside the box. So the variable name is case sensitive. So if you have a capital V variable, that's the variable, that would show up in a different, it wouldn't be recognized if you tried to use that with a lowercase v variable later on. That's more confusing than it needs to be. It's case sensitive, so yeah, you always have to refer to the variable in the exact characters. It just doesn't work if you change some of the cases. So yeah, every new variable has to have a unique name from any other variable that's in the program already. There's only 3 ways that you can start a variable. So you can start it with a letter. So just the name of a variable, like message, like we saw, any letter is okay. Or it can start with a $sign or an underscore. But it can't start with a number, for example. You couldn't have a variable called 3 dogs that has some text in it. That wouldn't work. It has to be the letter, $sign or an underscore. There are some words which are called reserved words, which we're not allowed to use as a name of a variable. So for example, we've seen some of these already, like var, let, and const. These are words that JavaScript explicitly knows about. And if it sees the word var, it's going to assume, okay, the thing after it we're initializing a variable to. So if it sees var, something var, for example, it would break because it's like, okay, we're creating a new box, we're calling it, and then it's like, oh, we're creating a new box, and it's called whatever's on the next line. So we'll get an error if we try to use a reserved word. There are a bunch of these reserved words that we should know about, but we can look those up, and your console will just yell at you, telling you if you've used a reserved word that you didn't know about. Okay, and yeah, the meaning of the word is quite important. So you want to try and make variables that are quite expressive to what should be inside of the variable. So again, just think about, okay, we're making a box with a name on it. Let's try and be organized and give the box a sensible name so that when we come back to it a year later to clear the box out, we know what's going to be inside that box. There's quite a famous quote from this guy, Phil Carlton. He was one of the first developers of Netscape, so the same company that Brendan Eich was working for, one of the first web browsers. And he said, there are only two hard things in computer science: cache invalidation and naming things. So the cache invalidation, I'm not really sure what this is, but I think it's basically something really complicated to do with making a web browser. And naming things is always one of these difficult things. Coming up with the right name for a variable is a sign of like a really good programmer in general. And it's one of these hard things that just comes eventually with practice, with sort of figuring this out enough times. So once we've declared one of these variables and once we've assigned it to a value, we can use a variable anywhere inside of our code by calling that variable name. So for example here, we're creating a variable called number of kittens box with this name tag of number of kittens. We're putting the number 10 into the box, and then we can console.log that variable, and it will give us back the number 10. That's kind of the basic outline of how these variables work. And then what can go inside of these variables? There's basically 5 different options of things that you can put into these variables. We can use numbers, we can use strings, we can use, so a string is like a string of characters, basically. This is used kind of everywhere in programming. A string of characters looks something like this. We can put what's called a Boolean value. So that's like the letters true or false. So this can also be thought of as like 1 or 0 or on or off, yes or no. This comes up quite a lot. We'll talk about this in more detail in the next lecture. It can also be what's called undefined, which means that we haven't given it a value. So when we initialize a new variable, let's say let favorite things, that creates the box called favorite things. But unless we assign something to it, then by default it has this value of undefined. So that's also one of the data types that we have to work with. And then finally, we can also assign something with the value of null. And null means that something is explicitly nothing. So good pickup lines here, we're creating a box called good pickup lines, and it's not undefined because we're actively saying, okay, this wants to be nothing, this wants to be null. So that's different from undefined. Undefined just means we haven't yet defined it. Null means, okay, this is nothing, this is empty. Okay, so I'm going to go through each of these data types. We're going to talk about numbers and strings and what we can do with numbers and strings in this lecture. And the next lecture, we're going to talk about Boolean values. Okay, so numbers. So in general, numbers, there isn't a difference between an integer value or a float value, like a number with decimals. JavaScript recognizes both of these just as numbers. That's actually quite convenient based compared to most programming languages where you need to define something as either an integer or a number with a decimal. So all of these convert to numbers, basically. When it reads an integer or reads a float, it converts to numbers. There's also like a subtype of numbers called not a number, NaN. And usually if you get an NaN, this basically means that something went wrong with the execution of some operation. And you did something that you're not supposed to do. So you could be minusing Jane Lane from true, for example. It technically wouldn't break the program, but you would just get something called not a number as a result. You're not allowed to minus a string from a Boolean value, basically. So in terms of operators for numbers, again, operator is just something that you can do with a number. It's a kind of scary word, but I think you kind of get the gist of what an operator is just from seeing how it looks. So for numbers, we have arithmetic operators, which is just really simple stuff like plus, minus, divide, times, basically. So here, we can have these two variables, and we can create a new variable, which is this one plus this one. So this one's 5, this one's 4. This number of animals total would be 5 plus 4, which equals 9. Okay, so here's a full list of all the arithmetic operators that we have to work with. So this is quite simple, just like regular maths. You can add two numbers together with the plus sign. You can minus one from another. Multiplication, you use the asterisk. And division, you can use a slash. So the only two that might be kind of not super obvious is that if you put a minus sign before a number, then that gives you the negation of that number. So if you say minus 5, that's minus 5. If you have minus of minus 5, then that becomes plus 5. So it's like kind of like the opposite around 0, basically. And the other one that you might not have heard of is the modulus operator. So if you have one number, then a percentage sign, then the other number, it basically finds the remainder of this number divided by this number. So this is something kind of computer science-y. You wouldn't really use that much in day-to-day life, but it can be quite useful every now and then, a sort of a better solution to a particular problem. So an example of this working would be to say, okay, if we had 32 modulo 2, that would equal 2. You think, no. 30 modulo 10. 30 modulo 10. So 30 divided by 10, the remainder is 2. So the result would be 2. We don't really use this all that often, but just for completeness, that's all the arithmetic operators that we could use. So a super quick demo here. So I did this already. We have this number of 2 plus 4. I'll just show a couple of examples. So we could say, okay, 3 times 10, 30, easy enough. We could store this as a variable. So we could say const big num equals 100 plus 140. Sometimes we get undefined as the result here. The reason behind that is that we're just it's logging out the return value of this statement. So don't worry about this right now, but we could write console.log big num, and then we get the actual value. But still it says undefined, which is kind of confusing. I don't have a great explanation for why it's doing that, but don't worry about that for now. Okay, so then we might want to say, okay, big num, it's 240, modulo, this fancy new one that we came up with. If we did 240 modulo 24, we get back 0. So it's saying, okay, if we divide 240 by 24, what's left over ends up being 0. Just one more thing for this not a number thing. A way that this could happen is to say, okay, what if we did big num, which is 240, plus 3, but in quotation marks? No, that doesn't work. Okay, this is something different. I'll explain it with strings. Okay, let's try big num minus hello. Yeah, we get this not a number thing. So we didn't get an error, but the result of this value is something that JavaScript couldn't figure out. It's not a number. We're not allowed to use a minus sign between a number and a string, basically. Okay, so hopefully that's helping a little bit to see a tiny bit of an example. As always, I think to really drill this into you, to figure this out for yourself, I think the code camp exercises, the homeworks, will be way better than me just giving a quick example. But hopefully this is at least good to sort of escalate your learning on it and get you to that point a lot quicker. Okay, next data type I want to talk about is strings. So strings stand for strings of characters. So one letter after another, surrounded by either single quotes or double quotes. We can do either. If we've written something in single quotes and we want to actually write, a single quote, like an apostrophe, we can escape this character by putting a backslash before it. So we in a console log, I'd like to use an apostrophe. To make sure that it doesn't break, we can use a backslash before the apostrophe, and that makes it work. So there's a couple of string operations I want to talk about. There is a plus operator with strings, which is where this was going wrong. With strings, if you have two string names next to each other with a plus sign in between, then there's an operator called concatenation, which adds this string onto the end of this string, basically. So it says, okay, I want this string and this string. I want it to be sort of smushed together and just have one string. That's what the plus operator does. There's also an operator called the plus equals operator. So plus and an equals next to each other. What this does is mutates this original string and shoves whatever's on the right of this onto the end of this. So this syntax here is functionally equivalent to this syntax here. We just don't need to repeat the name of the variable 2 times. And in this case, we're just keeping the name, the kitten name, rather than creating a new variable called full name. So maybe that's a little bit more clean, a little easier. So the way to remember this is, an image like this. Concatenation is, a cat jumping on another cat, and that's sort of like one being sticking to each other. So hopefully this helps. Maybe this helps. At least a funny cat pic. So if we want to combine a string and a number, sometimes we have a little bit of a problem with this. So I just want to introduce this. We could be doing something like this, where we want to add numbers together and put the results in a string, or we want to be able to list a number as a string. It turns out if we use the regular plus operator, then this works. But I think it only works if the string component comes first. So this example that we did here that didn't work. If there's a string and a number in general, your computer is going to assume that you want to do concatenation with a string. If we want to actually add a string of a number to a regular number, then we need to cast that string as a number. And the way to do it is with this string syntax. So in this case, let's say, okay, we have a number of 1, 2, 3, 4, 5. We can create a string representation of that number by passing that number into this capital S string function that we have. And console logging the string number here, we can see this number is sort of encapsulated in quotation marks. So our browser is gonna treat this number totally different. Like this is just a string of characters now, and this one is an actual number. So an example here, using pretty much the same example, going the other way. So we can also cast a string as a number. And to do that, we pass in the string value into this number function. And okay, so in this case, this is a good example of where this pops up. If we try string number plus 1, with the number as a string, this will log out a string of characters where it's 1, 2, 3, and then 1 sort of attached to the end of it. But if we want to actually add these two numbers together, then we need to first cast this number as a string, and then the plus sign in this context, because we have two integers, two numbers, is that it'll try to add these two things together. So these two are different operators that we're using in different ways. So that's why we might want to cast strings as numbers and numbers as strings. Okay, so the last block of this lecture that I want to talk about, I'm going to introduce functions in JavaScript. Functions are really important to allow us to block together particular units of code and make our lives way easier. That's kind of a really broad introduction. So we can think about this with our black box analogy from way back in week 0. We said that, okay, we get these really nice things called abstractions, where, okay, we can put in some sort of input, and we don't really need to care what's inside of this black box, what this black box is doing. We just need to put the input in the right format, and then we get back some kind of output. So one use case for functions is to basically just think of these as this sort of black box. We can create a black box, we can give that black box a name, and then we can use this black box with a particular input, and we can get back a particular output. So that's the frame that I want to treat this whole kind of section talking about functions as. We have inputs, we have outputs, and we have some implementation underneath that's doing things with them. So there's two parts to using a function. First of all, we have to declare the function. So similarly to declaring a variable, when we write let some variable name, we're saying, okay, give me a box with the name of the variable on the end of it. Just like that with functions, we can use this function syntax here to create what you could think of as a factory, basically. We're creating this magical black box factory, and we're giving it this particular name. So the syntax is always, okay, there's the word function, there's a space, there's the name we want to give it. Then we have some brackets, and then we have some curly brackets that some code is going to go inside. And okay, so we can have multiple lines in this function. It doesn't need to just be one line. This can be as long as you want. This can also call other functions inside of it. And the deal with this function is that if we invoke a function, so this is sort of like using the function, then all of the code inside of this block here will be executed line by line. So I think this probably makes more sense once we had some experience with it, and once we've seen a little bit more. So a function, you can think of a function as being sort of like Lego blocks. You have these sort of pre-made blocks of code that you can work with. You can call that block of code, you can use that block of code, and suddenly lots of lines will get executed, which is quite useful just in and of itself. But the declaration always has to come before the invocation. We need to like set up the factory. before we can like churn the levers and create some output from the factory, essentially. Okay, so the next thing I want to talk about is arguments. Another one of these just more and more jargon being fired at you, unfortunately, in this lecture. Again, don't worry about knowing all of this jargon by heart, being able to report to me, okay, what is an argument versus a variable versus a property, et cetera, et cetera. An argument is sort of like the input. An argument is one of the inputs that we can pass to a function, and we can pass multiple of these inputs at once and get a different output depending on what we put in. So an argument you can think of that's analogous to an input. And the syntax is in between these two parentheses, just after we gave the function a name, we can put the name of the argument that we want to use inside the function. And then inside of this declaration, we then have access to this variable inside of this block of code. And then to actually use the function, so before invoking a function, we just put the parentheses at the end of the function's name on a line kind of below this, let's say. If we want to use an argument, then we just pass in a value to use for this name here. So in this case, okay, we've got a function called call kitten. It takes a kitten name as an input, as an argument. And then when we run this function, we get this console log of come here plus whatever name we decided to put in. And here we're just cranking out this black box. We're giving it an input of a string of Fluffy. And as a result, we'll get a console log of come here, Fluffy. We can also have multiple arguments. So the second example here, this takes 2 arguments. Every argument gets separated by a comma. And so this is the declaration. We take 2 numbers and we console log these 2 plus together. And yeah, passing in add numbers 5 and 7, this outputs 12. And there's a slight typo here, but if we want to add numbers 9 and 12, this would output 21. So you can hopefully start to see how this becomes more useful over time. We can create more and more advanced calculators using functions like this to do lots of this sort of mental work for us. And we can also reuse these functions for different purposes. So it turns out that you can also pass variables into functions. It doesn't necessarily have to have the same name as the argument. So in this case, we have this add1 function. It takes a number. We make a new number, which is just that number plus 1. And then we're console logging, okay, you now have whatever the new number is, the number plus 1. So we could say, okay, add1, passing in number of kittens. And we can also say, okay, add1, passing in the number of puppies. So that's maybe a little bit different than just passing in the raw value. So, you know, another thing that we could have done is just say, okay, add 1 and then passing a number in directly here. So that's slightly different. So one thing I'll just mention here, it's a really common mistake to try to pass values into the declaration of a function. And this is something that will break it. And it might not be super obvious why something's breaking. Just be really aware that there is a difference between declaring a function and using a function. And when you use a function, that's when you can pass a value in. And that value can be a variable in this case. Okay, one other thing about functions is this concept of returning a value. So there's this keyword called return in JavaScript. And what this essentially does is it says, when you're running through a function, when a function's been invoked, it's going to give back whatever we have after the return value as the output. So again, going back to this like factory or box example, we have the black box, which is the function. We're passing in an input, which is one or many arguments that we're using for the function. And in terms of defining what the output looks like, that's whatever goes after this word return. So yeah, so let's say in this example here, we have this function called square. It takes one number, and we're returning that number times itself. So here we're saying, okay, if we console.log passing 4 into this square, this thing of square with 4 in brackets, this evaluates to 4 times 4, which is 16, and then we're console logging that value. We could also store the result of a function as a variable. So in this case, we have this variable called square of 5. We have this box, and we're initializing it to whatever we get back from calling this square function. If we didn't return anything, then this would always give back the value of undefined. So if we don't have this return thing, then it's basically saying don't set up the output yet, just return undefined. And yeah, so that would be just pretty much identical to just initializing an empty box still. Okay, the last thing I want to talk about in this lecture is the idea of scope. So scope is talking about where in the program it's possible to access a particular variable. And basically doing things with functions wrestles with this scope. So I'll give you an example here. So let's say we have this text variable, this string that we're putting in this box called awesome group. And we have a function called whatisAwesome. If we call this function here, this will run what's inside of this function. And we can access this value awesome group that we defined outside of the function. The explanation for this is that when we define something at the highest level of hierarchy, right outside of any other functions, and it's sort of at the top of the file, that's accessible from within our function. But on the other hand, if we define something inside of a function, we can only have access to that inside of this block here. So in this case, we're doing the same thing, except we're bringing this variable inside of this function. So in this case, okay, we've declared this function, we're calling this function whatisAwesome, we're invoking it. So JavaScript will see this, it'll bounce up to the start of this, it creates a new variable called awesome group, and it console.logs this message. That's okay. But then in the line below, we're trying to access this variable called awesome group. JavaScript basically can't see inside the function to see this variable that we created. This variable only exists in the context of being inside of these curly braces here. So this is called local scope. The variable is only accessible in this local context of being inside a function. And this part is called global scope. So it's available globally for any function in the file to understand, basically. Okay, so that's it for this lecture. This week's homework is mainly going to be the free code camp exercises. There's more of them this week because we covered lots of new syntax. For the regular homework, it's just doing the free code camp exercises, so it's hopefully quite easy if you don't like reading rather. And then the bonus homework, if you get onto that, there's some practice problems that you can check out on your local machine coding in JavaScript.